Hey, welcome back. So we're going to take a look at another example. So we want to write this basically as a volume expression. So remember what we're given here is we are given this function here, f of x, y. And we are multiplying the f of x, y by some area of a base, dA. And they give us that region they are from right over here. This is my change in x's, and there's my change in y's. So if we look at the base, right here, this is a rectangular base again, so my x's are going to go from -2 to 1, and my y's are going to go from 0 to 1. So we're taking this base, and remember, we're going to project it up. So I want to find the limits of my base, and that's going to give me right here, my r. So my r is my limits. So I have two limits here because I'm dealing with multiple variables. My base has to deal with the change in x's and my change in y's. We're looking at y there. So my change in y's, I always do my change in y's first because I always like to deal with a horizontal rectangle. And that rectangle is going to go from 0 to 1. My change in x's, well, remember, for my change in x's, what's going on here is that this vertical rectangle has to move from x equals -2 to x equals 1. So we're moving that vertical rectangle right and left from -2 to x equals 1. So when I want to write my volume, ready? It's going to be the value of my function, f of xy, dy dx. I'm going to be lazy. I'm going to use f of xy this time. I don't want to write that all out again. And this is a double integral because we're dealing with the two variables. Again, because I chose my vertical rectangle, I put y first. Vertical rectangle, therefore y first. That's going to become important for the next example. So my y's are going to go from 0 to 1, and my x's go from -2 to 1. And there we have it. So let's go ahead and practice typing this one in our calculator. Here I have the CAS. Okay, I would highly encourage you to get one. So if I type this in, menu 43, I'm just going to type in exactly as it looks, -2 to 1. Now, instead of typing in my equation, I'm going to go, again, menu 43. I'm just going to type in my next integral, 0 to 1. And now I'm going to type in my function right here. I was lazy, so I'm going to write out of here. We have x squared times, put a dot there. If you don't put the dot there in the CAS, sometimes we'll read the x squared, y squared as a function by itself. So put the dot there, plus cosine pi times x. I can never find the pi, but I just type in pi. Plus the sine pi times y. And then over here, remember my differential, we're using x, y's and x's. Order matters. Put the y first, and then put the dx. Press enter, and we get pi plus 6 over pi. Whatever that is, pi plus 6 over pi, which we can approximate that as 2.910 pretty much for our answer right there. All right, very good practice for us. All right, so again, if I want to try this one, let's take a look here. There's my function, f of x, y. This gives me my base. Now the base is our dA. It gives us our dA, our change in x and our change in y. So if I want to set this up here real quick, we would get, let's see here, looking at the base goes from 0 to 1, and the height goes from 1 to 2. So we have our rectangle here. Again, I'm going to use a vertical rectangle. So that's going to tell me my change in y, which is 1 to 2. Therefore, my change in x's, because this is moving right and left, goes from 0 to 1. And I can write my volume equation. The double integral, my function, 1 over 2x plus 3y squared dy dx, remember my change in y is now go from 1 to 2. My changes in x goes from 0 to 1. The order doesn't matter, but that would be your answer right there. And you can just type that in your calculator. All right, for the next one, it gets a little bit different. We want to find the volume of the solid that is below the surface. So what are they giving us here? They're giving us the height. This is our function. So this is my height equation right here. Over the region R on the plane, z equals 0 is part of my plane. So z equals 0. So that's basically saying we are on the xy plane. How nice of them. What if we're not on the xy plane? Then we'll talk about that tomorrow. Bounded by the curves x equals 0, y equals 0, and this line. These are our constraints. Just like last year when we find area and volume, they have to give us these constraints. And we are bounded. These are bounded, and they're on the xy plane. So they're giving me constraints on the xy plane. So if I draw this, this is going to give me my base. My one constraint is x equals 0. That's just the y-axis. Y equals 0. That's the x-axis. And the constraint x plus 2y equals 4. Okay, well I can graph this. My x-intercept would be 4. My y-intercept, of course, would be 2. We'll look at this first quadrant. And so this is the region that we are bounding. So this is the region, ready, that is projected up to the surface. And this is the one we are trying to find the volume under. So we're going to project this up to where it intersects this plane right here. Remember, this is a plane. So we're going to project this triangle up. So it's going to make a gigantic triangular prism up until it hits the surface. And we want to find that volume. So now it gets a little bit trickier for us because I have to get our limits. The base limits. Now it becomes very important. See, in all the other ones, I could switch dy dx, switch my integrands, and be okay. Switch my dy dx, switch those, I'd get the same answer. But over here, it gets a little bit harder. Now the order really matters. Now, so I'm going to stick with my vertical rectangle. I've been doing it all along. So that's going to give me my change in y. This is my vertical rectangle. Well, to get my change in y, I need to know where I'm starting. Well, my bottom is 0. But the top is not the line x equals 2, but it's this line right here. And that is if you solve for if you solve for y, you get 2 minus 1/2 x. And that's going to be the top of our rectangle of mathematics. And I can write that 2 minus 1/2 x. Now, my change in x, therefore, well, what is x going by? It's going from left to right. And that's going to go from 0 to 4. So what would my volume equal? Well, it's going to be a double integral again. It's going to be my function, which I'm looking for, this 3x plus 2y. Because I'm doing vertical, delta y goes first, so dy dx. Remember, it's infinitely small, right? And my change in my y's are going to go from 0 to 2 minus 1/2 x, and then from 0 to 4 for my x's. And that would give us our volume right here. Now, a couple things to keep in mind when you are solving these. Okay, when you are solving these right here, remember, in the first integrand, it has to be in terms of the variable, but the variable has to be in the outer integral, the dx, differential there. Our last example here, a little bit tougher. Find the volume of the first octant part of the solid bounded by the following two cylinders. X squared plus y squared equals 1, and y squared plus z squared equals 1. So remember, this is a cylinder. This opens on the x axis, where this cylinder opens on the this axis opens up on the z-axis. There we go, because z is missing, and this one opens up on the x-axis. So I'm going to graph these the best I can. I'm terrible at graphing these. Okay, you guys are probably better at graphing this than I am. Okay, so we're only worried about the first octant, so that's nice. So that tells me we only worry about this part that we're seeing right here. If I graph the first one here, this is on the xy plane with a radius of 1. So 1, 1, looks like this, and it's opening up, like so. This one opens on the x-axis, where y and z are both 1. 1, 1, and it opens this way, opens along parallel to the x, perpendicular to the x. And what we have here is our surface right here. And I can't draw this to save my life, but you can kind of see this little surface that we're looking to find the volume of right here. So this is the surface we want to find the volume of right here. So how do we get the equation of this surface? Well, this is going to be f of xy, remember this is z, equals, well, if I look at the equation of the surface, this is just going to be the square root of 1 minus y squared. So that's my surface right there. Remember, this is z equals the square root of 1 minus y squared. I'm getting it from I'm getting that from our little equation right there. Now, the base down here is a quarter circle. And we get that by looking at our y equals, and we get that from our first equation. And that is from our x squared plus y squared equals 1. So I can say y equals, and we're only looking at the positive, so we look at the square root of 1 minus x squared right there. So I'm going to look at the base one more time. So here's my base. If I just look at the base on the xy plane, remember, this quarter circle, we're projecting it up to that part right up here, and that's going to give us our surface, our volume. So if I only look at the xy plane, right here, I look at my rectangle. There is my rectangle of mathematics. So because, again, I'm choosing a vertical rectangle, I am going to use my delta, my change in y first. Well, that's a weird looking y. My change in y is first. Well, the smallest is just y equals 0. And up at the very top here, remember, it's kind of like here. This is my little rectangle right in here. That's my little rectangle right there. We're going to do more about these later on. So that's going to be, the smallest is going to be 0. My tallest is at 1 minus x squared. So the square root of 1 minus x squared. My change in x is a little bit trickier. Be careful. Remember that change in x goes from right to left. Not trickier, easier. And that's just going to go from 0 to 1. So I can now write my volume, the double integral, my function I'm measuring up to, the square root of 1 minus y squared, dy dx, and it's going to go, my y's are going to go from 0 to the square root of 1 minus x squared, and then from 0 to 1. And that would give us our volume right there. So again, real quickly, ready? This is my base. These give us the base right there. And this is my height. Area of the base times the height. If I got rid of the dy dx from yesterday, that was the area of our xy plane, our area of our base. Multiplied by the height, we get our volume. Alright, I hope you enjoyed the videos. I'll see you guys later.